beat it. Good morning, everybody. Happy hump day to you. Today is Wednesday, May 27th, 2020, and we are going to review the quadratic formula. All right. So if you're just now tuning in to this particular video, um, go ahead and watch the playback of all the other videos so that way you can have a better understanding of what the quadratic formula is. I promise you we will be wrapping up quadratic formula today and we will be moving forward with some other mathematical concepts. Okay, so again, I just want to encourage you, if you don't know what the quadratic formula is, go all the way back to the very first video and it'll tell you everything you need to know. And I did hear another ding, so I just want to acknowledge someone else that's just joining us this morning.
Good
Good
morning,
morning.
Miss Philomena. Miss Philomena?
Yes. Oh, so you joined us this morning.
Yes, I came back on time.
Oh, okay, wonderful, Miss Philomena.
Yeah, I don't want to miss a sweet lecture.
Oh, okay, wonderful. Okay, well you can go ahead and put yourself back on mute, and we are going to go ahead and review the quadratic formula in its full entirety. So I'm just going to, pick out a couple of problems that are formatted differently, and we are going to go over those. And then after that, we should be, you know, what's the word I'm looking for? We should be very comfortable with the quadratic formula. I think we've been on this for probably maybe a week and a half, 2 weeks with factoring trinomials and then the quadratic formula. So again, if you still find yourself having a little difficulty with not only this concept but any other concept, please feel free to go back and watch the playback videos. Make sure that you're taking excellent notes. Make sure that you are, just following each step by step, because remember, math is repetitious, and the way that we learn things is through repeated processes and repeated orders. So it's very important that you make sure that you are following the steps and making sure that you know how to apply which step to what type of format that you may have. Okay, so we're going to go ahead and just knock this on out the park. And I'm going to go ahead and put my toolbar up. Hey, toolbar. All right, so I emailed out this sheet on yesterday, and of course, I know you can't see it, but I know I can't see it. So what I'm going to do is I am going to, let me see. I'm just going to pick a couple of problems that are formatted differently, so that way, again, you can see the difference in how to do them. All right. Now, I am going to circle. Yeah, I'm going to circle number one. So I will be working on number one. Number No, number four looks like a good one. So I'll do number four. I don't like how I wrote that, y'all. Real particular about my circles. Okay, so I'm gonna do number four, and then number, I think I'm gonna do number eight. Okay, so those are the three that I am going to be focused on. Remember, if there is another problem that you would like for me to work on or to take a look at, feel free to let me know. Okay. So let me scroll back up here to make sure that I'm writing down these problems.
Do we mention it now or later?
I'm sorry, what's that, Miss Philomena?
Do we mention the numbers that I would like you to work on now or later?
Okay, is there a particular one that you would like for me to work on?
Yeah.
Okay,
Number
what number is that, Miss Philomena?
number 15, number 16, number 4.
Number 16?
Then, yeah, number 15 too.
Okay. All right, so 31. Oops. That's 6. All right. And we have number 9 in, number 16. 9 in 4 plus 7. All right. Okay. Thank you so much, Miss Philomena. I copied those and we'll work on those as well.
Okay.
I don't like how I wrote that. All right. So we're going to go ahead and just get started. So again, go ahead and make sure that you all are on mute and make sure that your cameras are off. So that way we can, protect privacy and all that good stuff. All right.
Miss,
Yes, sir. Was there one that you wanted me to work on as well?
yes, ma'am. Number 12.
Okay. Well, I tell you what. Oh, okay. Number 12. That was a good one. All right. So I tell you what we'll do. We're going to go ahead and work on the ones that you all suggested. So because I think that would be easier, and plus they are different, totally different. So I'm going to go ahead and write those down. So forgive me if y'all see me looking off camera. I'm actually writing these down. Okay. Let me see. All right. Let me see something. Okay. Oh, wonderful. So that means I can do a screen clipping. Yay. Woohoo. All right. And for those who don't know, a screen clipping very quickly is when I can take something from another source, such as a worksheet or website, and I can clip it into my presentation. So I'm very happy about that. All right. So I'm going to go ahead and open up a new page here, and then I'm going to do a screen clipping of number 12, 15, and 16. Okay. All right. All right. So I have number 12 here. And of course, I'm going to make it bigger so that way everybody can see it. Because I can't see it. All right. Then I'm going to do another one, a new page, and one more new page for those numbers. Okay. Uh-oh. All right. So then we have number 15 and 16. Wonderful. All right, make that bigger so everyone can see that. All right, and lock. All right, and then we have number 16. These little things are so cool. All right. Yes, ma'am.
15 and 18.
You said 15 and 16?
And 18. 1 8.
Okay, if we have time, Miss Philomena, we will do number 18.
Okay.
Um, okay, let's see here. Okay, great. All right, do another screen clipping here. All right. All right. Okay. Thank you so much, Miss Philomena. You can go ahead and put yourself back on mute for me. All right. So let's see if we can go ahead and get knock these problems right on out. Because that's what y'all came here for. Okay. All right. So what I have to do now is I have to go ahead and write out, well, actually for number 12 is actually easy. And I say it's easy because we are only going to be dealing with a square root situation. Now, this is where, again, knowing how things work is applied. So the question I have is, what kind of problem is this? Is this an addition problem, multiplication? What kind of problem is this? And if you don't know, just simply say, I have no idea.
No idea.
Okay. So what we have here, this is a multiplication problem. Remember, anytime you have a number and a letter together and it's equaling a number, that is multiplication. Now, don't get thrown off at the fact that that variable is squared, because there's something else that you'll have to do. So in essence, this goes back to recognizing what kind of problems you're working with. Okay. So this is a multiplication problem. And I'm just going to put multiplication right there. I'm going to shorten it. Now, the opposite of multiplication is division. So what I'm going to do is I'm going to divide by 5. Because remember, the goal is you want the letter to equal a number. Okay. Now, when I do this, these 5s cancel out, and I am left with r squared is equal to 16. Because 5 divided by 80 gives me 16. Now, the good news is I have an r by itself, sort of, kind of. The problem is it's r squared. So that means I need to do the inverse or the opposite of squaring, which is square root. So what you would have to do is whenever you're left with a problem like this, you are simply going to find or take the square root. And you know, I don't feel like writing all this today, so let me go ahead and type it. All right. All right, so find the square root because we are dealing with something that is squared. Okay, so remember, anytime you have s squared, p squared, q squared, whatever, it really doesn't matter what the letter is. But if it's raised to the second power, that means, and it's equal to a number, that means you're going to have to find the square root. So in essence, this is what this would look like. And I know it's probably going to look a little weird, but I don't make the news, I just report it. All right, so I have r squared, the square root of r squared. And that is going to be equal to the square root of 16. Yes, sir.
So you didn't have to use the formula for that one, right?
Nope, not at all.
All right.
This was just a simple multiplication problem, actually. But they just threw in the square root to kind of just, throw you off. But in essence, no, you didn't have to. Not for this
It
one.
did throw me off. They succeeded.
Okay. Okay, there we go. Let me move you right there. All right. Just move it on over. All right. So when I find the square root of a number, remember, when I find the square root of a number, I am trying to find a whole number that I can multiply by itself, and I can get that answer. So when I find the square root of something squared, they cancel each other out. Just like addition and subtraction, they're inverse operations. Multiplication and division, they're inverse operations. Square roots and squaring are inverse operations. Just like cube roots and cubing are inverse operations. So what I'm going to have is this. My square root and my number 2 up here, they're both going to cancel out. Okay, so I'm just going to cross out my square root, and I'm going to cross my number 2 out to let me know that they cancel each other out, and I'm left with r. Now, of course, I can find the square root of 16. And my answer, and remember, with square roots, you have 2 answers. So my answer would actually be +4 and -4. So that would be my answer for number 12. Okay. Now I'm going to check my work again. You necessarily probably will not have the time to check your work on your math GED exam. However, you want to make it a practice while you have the time to study and practice to check your work to make sure that you didn't miss any steps, or that, to make sure that you calculate it correctly, and to make sure that you are on point with what it is that you're doing. So I am going to check my work here. I'm going to say 5. And this actually goes back to order of operations as well. So if you need any help with order of operations, I actually have a video up in my Freebie Friday playlist that deals with order of operations. So please make sure you go and check that out if you feel the need to review order of operations. All right, so we're going to go with the please excuse my dear Aunt Sally. We technically don't have any parentheses, but we do have an exponent. So we have 4 squared, which is the same thing as saying 4 times 4, and that gives me 16. Now I'm still keeping it in the parentheses because remember, parentheses also denotes multiplication. So the last time I checked, 5 times 16 is 80. And 80 checks out. So therefore, positive 4 is one of my correct solutions. Okay. Now I'm going to do the same thing with the negative 4. So I want you to pay special attention. Okay. So we have 5 times negative 4. Squared. And that's going to be equal to 80. Now, again, we're going to follow the rules of please excuse my dear Aunt Sally, Sue, Shamika, whatever your auntie name is that starts with the letter S. And we are going to say negative 4 squared is the same thing as saying negative 4 times negative 4. And that's going to also give me a positive 16. Because remember, 2 negatives multiplied together gives you that positive result. Okay. And of course, based on what we see up here, we know that 80 is equal to 80. So therefore, negative 4 is also a solution. So that means this answer checks out. Now, I will also say this. On your math GED exam, they're not going to write the answer out that way. What they're going to do is they're going to literally write it out. This is just the shortcut version of the answer. So you have a positive 4 and then a comma and a negative 4. Okay, so that is how it's going to be presented to you as one of the answers on your math GED exam. Again, I just wrote it out this way because I was running out of room, but just understand that this is a shorthand version of what you see at the bottom. Okay, so Mr. McFadden, did I answer your question? Okay, I guess I did. No news is good news. Okay, Mr. McFadden, are you still with us? Just want to make sure you're still with us.
Yes, I'm here.
Okay. Did I answer your question for number 12?
Yeah, it's
Okay.
still kind of confusing, but
Okay.
I do some more practice today. So
Okay. No problem at all. And remember, once this video is posted, you can go back, you can stop, you can rewind, you can pause, you can, these videos, remember, they are at your own pace. Okay. So you just have to take the time and make sure that you, again, are, writing down the notes and just following along. Okay. So that's all it takes, just practice makes perfect. All right, so now what we're going to do, we are going to mosey on along to the next problem. Now, with number 15, you're going to have to do a lot of maneuvering around, simply because this is not in the quadratic equation form that we want. Remember, you want, I don't understand why I keep wanting to write when I can type. I don't know why I keep doing that. All right. Okay, so the standard form of a quadratic equation is as follows. AX squared, make sure you put that squared up there. That's very important. All right, plus BX plus C is equal to 0. Oh, wow. I didn't mean to do that. Okay, is equal to 0 for A, B, and C are numbers. Okay, so remember, A, B, and C, they are numbers. A and B would be the coefficients, and C would technically be called the constant. But in just to make everything, clear, A, B, and C are the numbers. Okay, so that is what you want. You want the standard form of a quadratic equation, because remember, all quadratic equations, they are equal to 0. So that means for this one, we're going to have to move some things around to make that happen. Remember, you want to move everything on your left side. So that's your left, and that's your right. Okay, so you want to move everything on your left hand side from your right hand side. Okay. Hold on. Okay, I see I see why I did that. Oh my God. Oh, okay, either way. All right. All right, there we go. So remember, you want everything that's on your right hand side to be on your left. That's what you're looking for, because on the right, you want everything to equal 0. Okay. Now, that means you're going to have to remember your like terms. So I have a negative. So I'm going to start from this side, but I'm going to use what's on this side to prove my point. So I have a negative 3k squared, but I want to move it to the left. So that means I'm going to have to add 3k squared to both sides. Okay, so this is just reinforcing those like terms. And I think I have a video on that already, but if not, I will definitely be sure to put that up for the Freebie Friday video. Okay, so I am going to put plus 3k squared. Okay, so I'm going to put that there. And I'm going to switch colors so that way, you all can see what I'm adding. All right. So next, and this is technically written wrong too, but we're going to clean all that up. So next, I have I have a negative 2k over here. So that means I'm going to have to add 2k to both sides. Okay. So I'm going to add 2k to both sides. Okay. And then I have a negative 6 on my right. So in order for me to move it to the left, I have to add 6. Okay. Okay. So again, I'm going to explain this as thoroughly as I can for the people that's watching the playback. Okay. So my original problem was k squared minus 31 minus 2k, which is equal to negative 6 minus 3k squared minus 2k. Now, first of all, this is totally written in the wrong format because it's not even following the 8x squared plus bx plus c equals 0. It's not even following that. So what we have to do is we have to get it in this form. Because remember, quadratic equations, they are all equal to 0. So what all I did was simply take the opposite. So I have a negative 3k squared. I added 3k to both sides. Okay. I have a negative 2k here. So I added 2k to both sides. I have a negative 6. So I added 6 to both sides. Okay, so does everyone see what I did? Yes, no, I think I see it.
Yeah, man.
All right. All right. So now when I do all of this stuff, this is going to cancel out, that's going to cancel out, and that is going to cancel out because that's what I wanted to do. I wanted all of that to cancel out. Because when I do all of that, I am going to be left with 0. So that's what I want. I want on my right hand side, I want 0 to be on my right. So I did that. Now we're going to focus on the left side. So I have a question. What is 1 plus 3?
It'll be 4K squared.
Okay, that's right. Excellent job, Mr. McFadden. So that'll be 4K squared. Okay, now we notice here that we have a negative 2K and a plus 2K. So what is negative 2 plus 2?
0.
So that means on this side, I do not have a second term because that has canceled out. Okay. Now I have a negative 31 plus 6. So that's going to, I'm going to go ahead and just say that's going to give me a negative 25.
25.
Okay. So this is my equation that I'm working with.
Wow.
Okay. All right. So I'm at this point, I have to use the quadratic formula simply because I have a k squared here. I don't have a middle term. I have an ax squared. I don't have a middle term, but I have a constant. Okay, so I'm going to show you that you can still use the quadratic formula with number 15 versus with number 12. You really didn't need to do it. Okay, because it was only one letter and you don't, zeros take up a lot of time. Okay, so I now A. So the number that is represented by A would be 4. B, I am going to go ahead and put 0. The reason why I'm using 0 as a placeholder for this one is technically because it would be 0 because I have a negative 2K plus 2K and it gave me 0. Now, for all intents and purposes, I am going to go ahead and use 0 here. I'm not going to leave it out of the equation simply because it's a part of the equation, if that makes sense. Okay. And for C, I have negative 25. Now, if all goes according to plan, this is not going to be hard. It's going to be real simple.
Excuse
Yes,
me.
Miss Philomena, do you have a question?
Yes. 4k squared negative 25. Then if we are placing the standard form for the quadratic equation a equal to 4, I thought that b will be negative 25, while c will be 0. Can you explain that?
No, C would not be negative 25. I'm sorry, B would not be negative 25 because remember, when you are working in standard form, you have ax squared. So ax squared is represented by the 4k squared. Bx is technically represented by the negative 2k plus 2k because it follows that same format. Okay. So it's all about formatting and making sure that you're putting the numbers in the right spots. Otherwise, you will yield a wrong answer if you put numbers in the wrong place. Okay, so that's the reason again why I am putting B as being equal to 0, because if I follow my format of 4k squared, as a matter of fact, I'm going to show you. And that's probably what I should have did in the first place. That's okay.
It's nothing.
Yes, sir.
You can't square 0, right?
You can do anything with 0, Mr. McFadden. What is the square root of 0?
Zero.
Exactly. So you just answered your own question.
Cause
You
you
can do
know
it.
where it's b squared on the equation.
I know. We ain't there
Yeah.
yet, but I got you. We ain't there
Yeah.
yet.
Okay.
I got you. But hang tight because we gonna get there. So if I rewrite this equation, I is gonna say 4k squared, and I'm just gonna go ahead and say plus because zero is a neutral number. It's really not a plus. It's not a negative zero or a positive zero. Zero is just a neutral number. Zero. Let me put a line through that. Now, this is technically how you would have written this equation in the standard form. However, you don't need to write 0k because it looks like the word okay. So that's the reason why, again, I am using 0 for B because 4 would be equal to A, 0 would be equal to B, and negative 25 would be equal to C. Remember, the constant C or the letter C is a number that's by itself. It's not a coefficient. It's just a constant. So that's basically what a constant is. It's just a number that's by itself with no letter with it. Okay. So hopefully that has answered your question, Miss Philomena, as it relates to um why negative 25 is not B. So if you use negative 25 as B, your answer is incorrect. But we're getting ready to prove all of that right now. Okay. So now I'm going to rewrite this the way that it's going to be written out. So that way, you can see it. All right. 25 equals 0. All right. Oh, Lord, I'm running out of space. Oh, okay. Cool. All right. Hopefully, I got enough space. All right. So I'm going to try and attempt to write this entire equation over here so that way y'all can see it. Okay. So that's going to be x equals negative b plus or minus the square root, the square root of b squared minus 4ac, and all of that is going to be over 2a. Okay, so again, wherever I see an A, I'm going to put my number 4. Wherever I see a B, I'm going to put 0. Wherever I see C, I'm going to put negative 25. So now I'm going to write everything out. Do, 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 do. La, 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 la. And for the record, again, B is neither negative nor positive. So I'm just going to write 0 here. Never mind. Keep going. Keep going, Miss Hampton. All right. So I have 0 squared minus 4 times A, which is 4, times negative 25. And all of that is going to be over 2 times 4. Okay. And that is a parenthesis. Okay. I don't know if that's someone else joining us or,
It's
but,
me returning.
oh, okay. All right. I always like to acknowledge people when they come in or, so again, if you're watching the playback video, my apologies. All right. So now what I want to do is the goal is for me to get rid of the square root sign or the radical sign. I'm simply going to go ahead and do that. Okay, so that's 0 plus or minus. 0 squared is 0. I have a negative 4 times a negative 25, that gives me a positive 100. Positive 100 multiplied by 4 gives me a positive 400. And then, of course, I have 2 times 4 is equal to 8. All right. So now I'm going to mosey on over here, and I'm going to, excuse me, I'm going to finish this problem. So that's going to give me 400. So I can take the square root of 400. And that's going to leave me with a positive 20 and a negative 20. Okay, so I'm going to write both answers over here. Okay, so I have 0 plus 20 over 8. And then I have, hopefully, let me move this. Okay, now I'm not going to have enough room for that. And then so I have x is equal to 0 minus 20 over 8. Okay, so again, when you take the square root of a number, you're going to have a positive answer and a negative answer. 20 squared gives me 400. Negative 20 squared also gives me 400. So that's the reason why we have 2 problemos like that. All right. So at this point, it's just easy arithmetic. So down here, I have 20 over 8. And if I simplify that, that's going to give me 5 over 2. Yes, that is going to give me 5 over 2. My greatest common factor is 4. So I have 20 goes into 4 5 times. 8 goes into 4 2 times. Okay. So same thing over here. I have 0 minus 20. That's going to give me a negative 20. So negative 20 over 8. And of course, that's also going to give me a negative 5 over 2. So my answers are positive 5 over 2 and a negative. Whoa. Hopefully y'all can see that is a 2 at the bottom. 5 over 2. Okay, so remember, it's very important that you make sure that you are putting your numbers in the quadratic formula, that you're placing them in the right spot. Because if not, you're probably going to get an answer that looks like, oh my God, I don't know what I did. And you may have to go back and retrace your steps. Now, again, let me go back to number 12. Okay, so number 12, that was simply a multiplication problem. You have to make sure that you can recognize what kind of problems you're working with, because that's going to determine how you solve them. Okay, so again, this was nothing more than a multiplication problem because I had a number with a letter. Now, the kicker was they threw this squared part in there, and it's equaled to a number. So anytime you see anything like that, automatic, that's multiplication. That's a multiplication problem. Okay, so this was just a straight up multiplication problem. I didn't have to maneuver anything. I didn't have to move anything around. I just looked at it and, oh, that's a multiplication problem. Okay, so then I had to divide both sides by the coefficient, which was 5. And when I did that, I was left with r squared is equal to 16. So at that point, if I know something is squared, that means I have to do the opposite and find the square root. Okay, so as you can see here, all of the steps are the square root of r squared equals the square root of 16. Okay, now I crossed out my square root sign and my squared, or the 2 in the sky. to let me know that those are inverse operations and they cancel each other out. Because remember, you still want a letter to equal a number. And in this case, it's two numbers. Okay. Now, number 15 was kind of the same in the sense of we had a positive outcome and a negative outcome. Okay. But the difference between number 12 and number 15 was that we had to maneuver some things and move some things around because we are now dealing with the standard form of a quadratic equation. Okay. So we had to move all of these things from the right. We had to move them to the left because we want our right side to be equal to 0. Okay. So when we did that, we said 4k squared because 1 plus 3k is 4k. So again, this is reinforcing like terms. So you have to make sure that you understand what like terms are and what unlike terms are. Okay. And then over here, we had negative 2k plus 2k. Now that canceled out, but for the sake of conversation, I went ahead and wrote it in. You necessarily will not have to do that, or you don't have to do that because 0 is a neutral number. So 0 really is really not a coefficient, basically. Okay. And then I had negative 31 plus 6, which gave me that 25. So I can't believe I just, okay. Just can't believe that happened. All right. So now this one matches this format. AX plus BX plus C equals 0. Okay. Now I knew that I did not need that middle term. So that's the reason why 0 in this instance would be represented by the letter B because of the format that it followed. Okay, which is this format right here. Okay. So then we just put the numbers in the equation and we just solve. Okay. So let's see, I have 15 more minutes left and I want to make sure that I give the last two problems the time and attention it deserves. So if you're watching this playback video, if you have any questions over numbers 12 and numbers 15, please leave them in the comment section. Pretty please. I greatly appreciate it. Okay. Now, we are now going to look at number 16. All right. All right, here we go. All right, so I'm going to go ahead and lock that. So that way it will stay in place. Now, again, number 16, you're going to have to maneuver some things around simply because it is not following the standard format of a quadratic equation. So this is my left. This is my right. I need everything from my right to be on my left. So when I do that, I am simply just going to subtract 7n. Now, I understand that there is not another n or a like term that's on this left side. So anytime you see a number like number 16 where it doesn't have the like terms on the left side, you're simply just going to move it by using the opposite term. So again, because this was a positive 7n, on my left side is going to be a negative 7n because I moved it to my left. Okay. Same thing with my constant, or same thing with the number 4. Because 4 is positive, I am going to subtract 4. But when I do that, I know that there's not another number on the left, but I'm going to move it and I'm going to then make that the negative. So when I do all of that, this is what I have. I have 9n squared. And that's going to be minus 7n minus 4. And that is going to be equal to 0 because these two cancel out on my right side. And that's what I want. Okay. So now this is the equation that I'm going to use in the quadratic formula. Okay. So let's see. I have A, I have B, and I have C. All right. So A is represented by the letter, I'm sorry, by the number 9, instead of the letter 9. Okay. B is represented by -7. Remember, the number always takes the sign. And C is represented by -4. Okay. So these are the numbers that I'm going to be using in my lovely quadratic formula. And y'all know Miss Hampton is a creature of habit, so I have to write these things out. -B plus or minus B squared minus 4AC. And that is over to A. Hey, hey, hey. All right. All right. So now, can anybody tell me if I substitute these numbers for the letters, what I'll have in my equation, or as my equation, rather? So I have -7, because that's represented by B, and that's going to be plus or minus.
Excuse me, Miss Hampton.
Yes, ma'am.
We need number 16. 4, 4 and -4. I was thinking it's going to give us a 0. So we're having -4 as the final.
No, 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 no. This is the equation that I'm using, Miss Philomena. I can see where you would say that, because the 4 and the -4 is under there, but
Mm-hmm.
it's not. So we know that when I cross it out like that, we know that that's 0.
Okay.
Okay, so I just want you to solely focus on the equation right here, because remember, when I cancel 4 and -4 out, that is going to give me 0. Was that a better explanation? Did that make sense?
Yes.
Okay. All right. So now I have -7 squared minus 4. Can't forget about that squared, y'all. 9 times -4, and all of that is over 2 times 9. And that's the number 9. It's not the letter A, just in case anybody was wondering. Okay. Clean that up. Perfect. Now, at this point again, we are going into regular schmegula math as it relates to multiplying integers and all that good stuff. All right, so remember, 2 negatives give me a positive. So now I have 7 plus or minus. -7 times -7 is a positive 49. I have -4 times a -4. It gives me a positive 16. 16 times 9, I want to say that's 144. But let me triple check myself to be sure. I'm sorry.
That's correct.
Okay, thank you, Miss Philomena. Okay, so that's going to be added 144. Okay, so now remember, 2 negatives, -4 times -4, positive 16. 16 times a positive 9, positive 144. So that's the reason why we go from this negative sign to a positive sign, because of integers yet again. So again, we can't get away from these integers, y'all. It's just a part of algebra, I guess. And of course, 2 times 9 is 18. Okay, so now I'm now going to add what's under my square root sign, which is 144 plus 49. And I think that's going to give me 190, 193. Yeah, I think that's going to give me 193. Okay. Yep, that is going to give me, yeah, 193. Let me check. Let me make sure. Pull up my calculator here. Hopefully y'all can see it. So I have 144 plus 49. Hey, 193, turn up. All right. Over 18. Now, 193 is not a perfect square root, meaning there is not a number that I can multiply by itself or together that would give me 193. If I put in 193, and I'm going to pull my calculator up to prove this, it's going to be 13.8 blah, 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 blah. So you do not want to literally find the square root of a number unless it's a perfect square. Okay. So my final answer, once I do all of that, it is simply going to be 7 plus the square root of 193 over 18. And I say and I'm going to write it out the way that you would see it on your GED exam. It's going to be 7 minus the square root of 193 over 18. So that is your final answer. You don't have to go any further and actually find the square root of 193 because, as you saw, is not going to be a whole number. It's going to be close, but it's going to be a decimal. Okay? All right. My water was behind. All right. So now I have one more problem. And I don't know if I can do it in 5 minutes, but it's worth a go. All right. But before I move on, do I have any questions at all as it relates to these problems that we're going over? Woo, water's refreshing. Okay, no news is good news. So we're just going to proceed with the last problem of today. Wow. Okay. All right, there we go. Move that up. Then I'm going to make it bigger so y'all can see it. All right. Then I'm going to lock it in place. All right. So with number 18 is pretty simple. Simply because we only have to move one thing, which is wonderful. Number, I think 16, we had to move several things to the left. But for number 18, we only have to move one thing. And the only thing we have to move is this -7. The way we're going to move the -7 is by adding 7. So this, because these two are numbers, I am going to add 7 under my 15, my -15, excuse me. Okay, so remember, this is your left. That's your left. And this is your right. You want your right side to equal 0, as always. Okay? You want your left side to be the equation itself. So when I do that, I have the following. I have 8n squared plus 7n. Now, I have a -15 plus 7. That is going to yield me a -8. And that is going to be equal to 0 because -7 plus 7, they cancel each other out. Okay? So does everyone see how I came up with the with that particular equation? Okay, 7n, that's minus. Okay, great. All right. So now what I have, A is equal to 8. I have B is equal to 7. And then C is equal to negative 8. All right. So those are the numbers that I'm going to be using in my quadratic formula. Do, 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 do. All right. So when I do that, I now am going to have the following. Okay. I have x is equal to negative 7 because remember, b is negative. B is negative in the equation. So because I have a positive 7, I now have a negative 7. So again, you got to know how positive and negatives work. Okay. And that's going to be, okay. Okay, cool. Plus or minus. Okay, I don't even like how I wrote that. All right. All right. Plus or minus, that's going to give me the square root over 7 squared. Okay, that's going to be minus 4 times A, which is 8, times C, which is negative 8. Okay. All right. That was my alarm. Okay. And all of that is going to be over 2 times 8. All right. So now, again, this is just regular schmegula math. Okay. I have negative 7 plus or minus. 7 times 7 gives me 49. Okay. And then I have a negative 4 multiplied by a negative 8. That's going to give me a positive 32. 32 times 8. That 256. I feel like that's 256. I honestly could be wrong. So let me check myself. Okay. So I have 32, and that is times 8. Okay. So that's a positive 256. Okay. And that is going to be over 16 because 2 times 8 is 16. Now, 256 plus 49. Let's make this very quick. 305. Shout out to Miami. 305. 305. All right. So I have negative 7 plus or minus the square root of 305 over 16. Now, again, 305 is not a perfect square simply because there is not a number that I can multiply by itself and they'll give me 305. Like, this is not possible. And I'm going to prove that right now with my calculator. Find the square root. See, that's a decimal. So you don't want to deal with decimals. So my final answer would simply be this. Negative 7 plus or minus, well, hold on. Here we go. That's going to be over 16. And -7 minus the square root of 35 of 305. Okay, 305, and that is going to be over 16. So those are my final answers. There's no other answer that is going to, do. These are your final answers. Okay. Now, I am 3 minutes over our time, and I kind of did start a little bit late. So my apologies for that. But I will say this: it is very important that you make sure that you are practicing these steps. It is also very imperative that you make sure that your fundamentals of math is strong, meaning your integers, your fractions, your multiplication. Those things are nothing but reinforcements in the quadratic formula. We're multiplying integers, we're dealing with positive and negative numbers. The quadratic formula is nothing more than a big old fraction anyway. So you have to make sure that you recognize that the goal of the quadratic formula is to simply make your answer as small as possible, because that's what the quadratic formula is. It's just a huge, complex, weird looking fraction, but we know how to deal with fractions. Okay, so I want you to take those jewels that I just imparted into you, and I want you to apply it to each problem, and I want you to make sure that you're asking yourself those questions. Okay, do I have to move anything over? Do I have to, shift anything from the right side to the left? If your answer is yes, you have to make sure that you know what like terms are. Okay, making sure that you put the number in the right spot. So going back very, very quickly, -7 is a number by itself, it's a constant. So that lets me know, oh, well, that means I am going to put it under here and not under here and not under there. Because remember, you cannot add nor subtract unlike terms. Okay. So again, you have to make sure that you know what to do with like terms and what not to do with like terms. Okay. So then when I did that and I put all my numbers in for the letters in the formula, I'm dealing with multiplication here. So this is nothing more than multiplication. This is multiplying integers. This is multiplication. Okay, this is straight addition. I can't find the square root of 305. I mean, I could, but that'll give me a decimal. So again, making sure that your foundational math skills are very, very strong. Otherwise, you may find this to be difficult. And to anybody that's watching this playback, I do have a fundamentals of math video playlist that I just created. And I'm going to talk about all of those fundamental things that you need so that you can be strong in math, going from fractions, decimals, and percents to integers. I think I got integers up already, and part of fractions. Okay. And each of the videos that I put out, they come with a practice sheet. Okay, so I just want to encourage you, please take advantage of the resources that are given to you. Okay, YouTube is your friend. I promise you, YouTube is my friend. So I want you to take advantage of all of the resources that you can and give yourself time to formulate and work through the problems. If you find yourself working on the problem for too long, skip it and go to the next one. Because at this point, I want us to be fine-tuned and sharp for when we're ready to take our math test. Okay. And like I said, I've been hearing stories about when they're going to open back for testing. I'm not quite sure, but once I get that information, I will be sure to post it in my virtual announcements video. Okay. Hopefully, it'll be by the end of this week that I hear something. Okay. But in the meantime, in between time, I want you all to continue to practice on the quadratic formula. Tomorrow is a potluck day. So if there's any other math concepts that you would like for me to go over in class, please send me a text today, today, and let me know what those concepts are so that way I can prepare worksheets, I can prepare additional resources that can help you. Okay, so tomorrow is a potluck day. And if you don't come up with anything, I already have something planned. So it worked out great. All right. So With all of that being said, I'm going to go ahead and stop this screen share. But before I close out, are there any questions at all over what we've done today?
No, ma'am. Just gonna need some more. That's
Oh, you were breaking up, Mr. McFadden. What you say? You said you needed what? You were breaking up.
I say they. It's gonna. I'm gonna need some more practice with it. That's all.
Okay. All right. Well, the resources are already there for you. All you got to do is just grab them by the horns and just do it. What Nike's little motto used to be, just do it. So that's what we got to do. Okay. So I'm going to go ahead and stop this screen share. And if there are no other questions, please make sure that you all text me or email me your concepts that you want to go over for Potluck Thursday tomorrow. If you don't send me anything, I already have something ready. See, you always got to stay ready. Okay. So, again, thank you all so much for your willingness, your consistency in coming to class. Ms. Hampton really, really appreciates you, Miss Philomena and Mr. McFadden. And for the people that's watching this playback, thank you all so much. I really do appreciate it. Please like the video, subscribe to my channel, comment in the comment section, and let me know what it is that I can do to improve. Let me know what it is that I need to do because I am a novice at this, but I want to make sure that I am helping people that genuinely want the help, genuinely need the help, and that is accessible for everybody. Okay. So if there are no other questions, I will see you all tomorrow for Potluck Thursday. Miss Hampton loves you. There's absolutely nothing you can do about it. Not that you should want to do anything about it anyway. All right. So I will see you all tomorrow. Bye.